Okay, folks, for this lesson, we're going to learn our third method of solving a system. Remember, a system is two or more equations working together to find the point of intersection, the point that they have in common. We learned how to graph to see that intersection. We learned one algebraic method called the substitution method, where one of the equations has to have one variable isolated. And now we're going to take a look at the second algebraic method of finding the intersection of our two equations, and that's called the elimination method. Again, remember, we can have exactly one solution where the two lines cross. We can have infinite solutions where both equations cross at every point, or we could have parallel lines and the two lines will never intersect, therefore there are no solutions. So remember, if two equations have the same slope, have different slopes, then they are going to eventually cross. If two equations have the same slope and different y-intercepts, that means they start at different places and they change at the same rate because they have the same slope. And that means there are no solutions and they will never intersect. So if you want, you can pause the video and write all of these steps down. However, the main thing with using the elimination method is that you need to make sure that at least one pair of variables, either the x's or the y's, have opposite coefficients. Also, this method is usually used when our equations are written in standard form, which is ax plus by equals c, where your x and your y are both on one side of the equation. But again, make sure you take step 1 in your notes. At least one pair of variables have to have opposite coefficients. And if they don't, then we can make them have opposite by multiplying by a value. So let's just get started. Here's example 1. We have the system 4x plus 8y equals negative 12. And we have negative 4x minus 6y equals 18. Notice they are written in standard form, so that's a clue that I'm going to use the elimination method. So I'm going to ask, do I have a pair of opposite variables? Yes, 4x and negative 4x are opposite. So now I can just simply combine the two equations and I can eliminate a pair of my variables. So I'm going to add these two equations together. So I'm going to put equation 2 underneath equation 1, and you're going to combine. So once you have a pair of opposite variables, you are going to combine the equations. So when I add 4x and negative 4x, the x's are eliminated. When I combine my y's, I get 2y, and I combine the constant, and I get positive 6. Now I can simply solve for the value of y. I'm going to divide each side by 2, and the y value for this solution is 3. So let's make a place for our solution, our point of intersection. Again, make sure you put the right variable in the right spot of your ordered pair. Now I'm going to take the value that we just found and plug it into either equation 1 or equation 2. I'm just going to work with equation 1. It doesn't matter which equation. So I'm going to have 4x plus 8 times the value of y equals negative 12. I'm going to multiply 8 times 3, and now we're going to solve for x. Subtract out 24, and I have 4x equals negative 36. We're going to divide each side by 4, and the x value looks like -9. So -9, comma 3 is the place of intersection. This would be in quadrant 2, negative, positive. So quadrant 2, somewhere our two lines at -9, comma 3 will crisscross. Let's take a look at example 2. Again, notice both equations are written in standard form. This lets me know I should use elimination. I'm looking for a pair of opposite x and y's. We do not have. We have a 3x and a 5x and an 8y and a 4y. So we need to either make the x's opposite or the y's. I'm going to choose to make my y's be opposite coefficient. So I need this positive 4y to be the opposite of this, which will be negative 8y. That way, when I combine, those variables will eliminate. So how can we make 4y into negative 8y? That's what we need. Well, we could simply multiply this whole equation by -2. So I'm going to make an equivalent equation. So -2 times 5x is -10x. -2 times the 4y is that -8y. And -2 times 24. So you have to multiply it all the way across. Now this is my new equation 2. It's an equivalent equation. So now I have a pair of opposite variables, and I'm going to combine equation 1 with my new equation 2. We're combining. When I add the x's, I get -7x. My y's are eliminated. They give me 0, which is the goal is to eliminate a pair of your variables. And now I have a -56. Now we can solve for x. And my x value is +8. So let's make a spot for our point of intersection. Now I'm going to take this value of 8 and plug it into any of the equations, equation 1, equation 2, or my equivalent equation 2. I'm just going to plug it into equation 1. 3x is 8 plus 8 times y equals -8. Multiply 3 times 8. Solve for y. Divide by 8. And the y value is -4. So this point of intersection is in quadrant 4. So at 8, -4, my two lines will intersect. Let's take a look at example 3. My equations are in standard form. I do not have a pair of opposites. I could easily make this -5y into a +15y. So I'm going to multiply. I need it to be +15y. So to get a +15y, I need to multiply by -3. So my new equation 2 is going to be, and I'm going to distribute your -3. We're going to get 12x plus 15y equals -9. Remember to multiply all the way across. Now this is equation 2. I'm going to combine it with equation 1. Our x's are now 15x, my y's are eliminated, and my constant is -30. We're going to solve for x, and x is -2. Let's make a spot for our point of intersection. -2 is x. I'm going to take negative 2 and I can plug it into any of my equations here. I'm going to use equation 1. Replace x with negative 2 and solve. I'm going to multiply, get negative 6 minus 15y equals negative 21. We're going to add 6 to both sides. Let's divide by our coefficient, negative 15. And our y value is positive 1. So our point of intersection would be in quadrant 2 at negative 2, 1. And the lines would cross. Example 4. I see that I have a negative 7y and a negative 7y. So they're almost what we need, but one needs to be positive and one needs to be negative. So let's just multiply this first one by negative 1. You could have easily multiplied the second one by negative 1. There are multiple ways of solving these guys. So I'm going to multiply and we'll get negative x plus 7y equals negative 21. So I'm going to combine equation 1 with equation 2. And now we're going to get 5x, our y's are eliminated, equals negative 35. Solve for x, and our x value is negative 7. Now I'm going to take this negative 7 and I'm going to use my original equation 1. So x is negative 7 minus 7y equals 21. Let's add 7 to both sides. Divide each side by negative 7. And our y value is negative 4. So our point of intersection is in quadrant 3. Negative 7, negative 4. And our lines would crisscross here. Okay, this is our last one, and I want to show you what you would do if you have to multiply both equations by some number. Because 6 and negative 9, I cannot make 6 into positive 9x or vice versa. And then we have negative 2 and 5. I can't just multiply one equation to get that opposite variable. So I have to take a look and see what I can do. And I like to use the smallest numbers. So we have 6 and we have 9. So if we are going to find the least common multiple, this would be 6, 12, and 18. This will be 9 and 18. So I could try to have coefficients of 18 and negative 18. Or let's take a look at the y's. We have 2 and 5. So the least common multiple here, we would have 2, 4, 6, 8, and 10. Or we would have 5 and 10. So I think I'm going to go and multiply to make this y value be negative 10 and have this y value be positive 10. So I'm going to multiply the first one simply by 5 and positive 5 because my signs are good. I have a negative here and a positive here. I'm just trying to change this value here to a 10. So I'm going to multiply through by 5. I get 30x minus 10y equals 10. Now I need this positive 5y to be 10y, so I have to multiply through by 2. And we get negative 18x plus 10y equals negative 34. So this is my new equation 1 and my new equation 2. So we're going to combine those together. And when we combine our x's, we're simply going to get 12x. The y's are eliminated. And here I'm going to get a negative 24. We're solving for x. And our x value is negative 2. I'm going to take that value and plug it. I'm just going to use equation 1, the original one. 6 times negative 2 minus 2y equals 2. We have negative 12 minus 2y equals positive 2. Add 12, bring down negative 2y, divide by negative 2, and our y value is negative 7. So our point of intersection is in quadrant 3 at negative 2, negative 7, and the two lines would intersect here. So I hope this method of elimination helps you.